In accordance with the customs of this university, I open the ceremony with the following words. Spiritus Sancti, gratia illuminet, census et corda nostra. Please take your seat. I would like to welcome the candidate, the family, friends, colleagues, the academic community in general, and the doctoral examination board, particularly its international members, to this ceremony. And I would now give the floor to the candidates to the degree of doctor.
With the permission of the doctorate board, and in order to obtain the degree of doctor from Radboud University, Nijmegen, I would like to defend in public my dissertation entitled The Face Says It All, Investigating Gaze and Affective Behaviors of Social Robots. With the recent advancements in the fields of AI and robotics, we see increasingly many companies coming up with their prototypes of robots with a clear intention of mass producing these robots. And this is perhaps indicative of a future where we'll see increased presence of robots in our society, and thereby more options or more interaction possibilities in our day-to-day life with robots. Just to give you an idea of what these robots look like. So this is a very famous robot from Boston Dynamics, and the intended use is in factory settings and warehouses. Then we have the Digit robot from Agility Robotics. Also, the intended use case is in warehouses, supply chain, and stuff like that. On the other end, we have robots like the one being developed by Tesla, and they intend to put a robot in our homes as our assistants. And then we have robots like Amica from Engineered Arts, which is mainly used for studying and investigating human-robot interaction because of its expressiveness. So as you can see, all these robots vary a lot on how they look like and also their intended use case. But one thing is common, and that is that they are intended to interact with us. And if we plan to interact with robots, if we want the robots to be able to interact with us, then one thing is common, that is that they should speak our language. But then in our day-to-day interactions, we do not just make use of speech, we make use of emotions. We express emotions on our face, we make use of gestures, or we make use of body postures in order to communicate our intentions and meanings. So if the robots need to communicate with us, then we definitely need more than just speech. And that's precisely what I have been trying to work on during my PhD research. Specifically, how can we make robots more empathetic, socially aware, and thereby making them easier to communicate with. To be more specific, I focused on the facial region of the robots because the face contains two very important nonverbal cues, the first being the gaze, which I discuss in chapter 2 and chapter 3 of my thesis, and the next being the emotional expressiveness of the robot's face, which I cover in chapter 4 and chapter 5 of my thesis. I used a robotic platform called the Furhat robot, which, as you can see, is quite expressive in the sense that it can express very human-like expressions and gaze behavior. So it made for a very appropriate platform for my research. So the first question that I thought of was, how can we automate the gaze behavior of the robot? And specifically look at the questions of where should the robot be looking at, when should the robot be looking at something, and how should the robot be looking at something when it is interacting with us. So we developed an algorithm. So the first two questions, where and when, that was decided by the algorithm depending on the conversation that is taking place. So let's say I'm the robot and I'm having a conversation with you, and I want to talk about this microphone in front of me. So maybe then I should be looking at the microphone. And when to look would be, perhaps when I am uttering the word microphone, I should probably direct my gaze at the microphone. Then comes the part of how to look at the microphone. So depending on if I want to discuss in detail about how the microphone looks like, maybe I want to move my head all the way and look at the microphone. Or if I'm making a passing reference, I will just do a quick glance. So that was the how to look at the internet object. To evaluate our algorithm, what we did was we invited pairs of participants for a user study. And the idea was that they come in and play a card game with the robot. And the task was that they sort these cards in a specific order, and which involved a lot of interaction with the robot and between the participants. So it provided for a very good test platform because there were a lot of glances being looked at the touchscreen as well as each other. We compared our architecture with the baseline. That was also an architecture which automated the behavior of the robot, gaze behavior of the robot. And what we found out was when the robot automated its gaze behavior using the architecture that we implemented, it was more interpretable and it was better at intimacy regulation. And overall, this was preferred more as compared to the other robot that was used for the test case. So this kind of highlighted the importance of having automatic gaze behavior on the robot. But then the next question came into my mind was, does the robot's gaze then in turn have any effect on the human gaze behavior? And to investigate that, we focused on the gaze aversion behavior, because gaze aversion is a behavior that is relatively easy to model on a robot, and also one of the important gaze behaviors that we use in our day-to-day life. To test this, we also conducted a user study with 33 participants, and what we did was we invited the participants to interact with two robots. In one case, the robot did not avert its gaze, and in another case, it averted its gaze using the gaze control system that I just explained. The setup was more of a question-answer setup, where the robot asks a question and the participant replies. And we tracked the eye gaze of the participants to see if they are directing their gaze at the robot or if they are looking away from the robot. And what we found was when the robot kept staring at the participants looked away more frequently from the robot. And also they looked away for longer duration when the robot kept staring at that. And this was, for the first time, we established a direct influence between the gaze behavior of a robot and the gaze behavior of a human. Next, I moved my focus a bit onto the facial expressiveness of the robots, and basically asked the question, how can we automate the expressions of the robot's face? And specifically, can we use a large language model to do the same? For example, large language models like ChatGPT that you might have heard of. So the idea was we take the conversation history, so whatever is being talked about between the robot and the human, send that to GPT, and then ask GPT saying, okay, based on what the conversation is so far, what do you think the emotion of the robot should be now? So then GPT perhaps predicted that, okay, the emotion should be happiness now. Then we feed that emotion to the robot and express it on its face. Now, to evaluate the architecture, we made use of an affective image sorting game. And the idea was that a participant comes in and plays a sorting game with the robot, where together with the robot, they sort a few images in a specific order, and the images were affective in nature, meaning that they had emotional content. So The images could be something like a girl holding maybe balloons and jumping around, so it's a happy scene. And on the other hand, it could be a grim scene, like somebody with flowers in front of a graveyard. So this allowed for the participant to have emotional conversation with the robot. And then we also wanted to see if the participants were able to perceive the emotions that are expressed by the robot and what are its effect. So we did that using 3 different conditions. In the congruent condition, basically the robot expressed what GPT predicted, the predicted emotion of the GPT. So if GPT says it's happy, then the robot would express happiness. In the incongruent condition, the robot would do the opposite. So if GPT says happiness, then the robot would express sadness on its face. And in the last condition, which was the control condition, no expressions were exhibited on the robot's face. And what we found out was when the robot expressed appropriate emotions on its face, the participants found the robot to be more positive, more emotionally appropriate, and more human-like. And most interestingly, when the robot exhibited appropriate emotions, we found that the participants scored higher in the collaborative task. So this kind of underlines that if we have relevant or appropriate expressions, emotional expressions on the robot's face, then that can help or influence the human-robot collaborative task in a positive manner. So in my research, I attempted to address the broader goal of making robots more empathetic, more socially aware, and thereby making them easier to communicate with, which is, of course, a requirement if we think of seamless integration of robots in our society. Thank you. Having presented this summary of my dissertation, I return the floor to the rector.
Thank you, dear candidate. I now give the floor to Professor Beckering to ask the first question.
Esteemed candidates, I was very impressed by the innovative nature of your thesis. To mention just 2 aspects, I very much liked your approach in Chapter 2, where you created a planning-based case control system in contrast to typically used reactive control system, as well as your implementation of large language model for emotion generation in Chapter 4. Thus I look forward to discussing these 2 innovative approaches with you. In Chapter 2, you find that your planning-based control system contributes to better interpretation and to more intimacy regulation. However, you don't find contributions to other measures like awareness or turn-taking. And you refer to the cognitive load theory to explain the absence of these findings. Can you explain why you think this is the underlying reason for the absence?
Dear opponent, thank you for the nice compliments and appreciating the research. To answer the question, I think it's got to do with the task that we used. As I also briefly mentioned in the paper, that it was a very engaging task. So most of the time, the focus was on getting the scores, getting the order correct, and also like that involved the gaze of the participant being directed at the touchscreen more. So they did not really pay special attention to the gaze. Many things were happening on the gaze behavior of the robot. So that could have been a factor, of course. And then, as I mentioned, so because this is a very engaging game, probably that kind of prevented them from paying attention to these subtle gaze cues. Specifically, like turn-taking gaze cues are very subtle in that sense. Whereas if you talk about the gaze cues like the referential gaze, they are like easier to perceive because, the robot kind of moves a bit more. So,
and do you also think that if they would be more familiar with the robot, that would also help them to see the gaze?
Perhaps that might be the case, but I think it still had a lot to do with the task. So I believe that the intention of using this task was so that we wanted to have one platform where we can exhibit all the behaviors that we are modeling in the model. But then I think if we want to verify these specific individual traits or the individual components of the model, I believe we should perhaps build focused studies to evaluate that better, like what was done in Chapter 3. So we focused on the gaze aversion behavior, and then we were able to measure both subjective and objective measures, and then come to a better observation about that.
No, so I see where you're going. So you think it's mostly because of the task, which was like a heavy cognitive load to perform the task. So if the task would have been simpler, you might have found it well. I think it might also be a lack of priors. So we use human gaze because we are so used to it. So we know what to expect. So that would probably be interesting to see if it's more like a lack of priors, or really that is more the task. Well, what would be? So your bet would be the task. Don't you think that the lack of priors, how to interpret the gaze of the robot, is also like a thing that you have to overcome?
I think that's definitely a good direction to look at it. But what I think right off the bat is, so we already have some evidence that humans do perceive the robot's gaze similarly in how we perceive human gaze behavior. And since the robot is like exhibiting the gaze behavior in a similar manner to how a human exhibits it, perhaps it might be interpreted in the same way, but it would be definitely good to take a look into this aspect as well, for sure. But I would still like focus a bit more, maybe in a less cognitive load of a task, and then pinpoint the specific components.
Yeah, I'm just thinking that it might also be indeed if the gaze would be really essential to perform the task. Yeah, that like if it would be like a joint action that you have to pay attention, that would also be one. Yes, thank you. So let's change to chapter 4. And like I said, I also very much like your implementation of large language models for emotion generation. I was really impressed by that, found it very innovative. And I was also actually impressed, I never saw it in your Ford robot, to see the Ekman facts emotional expression. If you just look at page 81, I'm like, wow, that's already like, I was not aware that you guys and your girls and everyone is already that far had a progress with that. That's really, was very impressive. But participants described afterwards to have experienced a more positive interaction when a robot showed congruent emotions compared to non or incongruent emotions. And I was thinking, like, how far do you think that the human-robot interaction can go on the emotional level? And, well, first I have an open question. How far do you think they can go? How far can the interaction go? In terms of understanding the emotional feelings of each other.
So, when it comes to expressing emotions on the robot's face, I think I break it down to why do we even need to, what is the need for a robot to even express emotions on its face? Not just because we can do it, but there should be a basis to it. And I personally think that this is basically to signal the robot's internal state. So it's not saying that, okay, robot is feeling these emotions or anything, but it's basically to signal that I have understood what you're saying. So let's say in a conversation, I am talking about something sad, and if the robot expresses sadness on its face, then I know, okay, I have been understood. So then I don't have to rely solely on a verbal confirmation saying, oh, that's so sad, but I can just express sadness and the participant or the user already understands that it's already there. So when I think about understanding each other's emotion, I think that's it's a different topic. Then we are going into the realm of like, is there understanding? Like I already am projecting that the robot has some mental model and feeling and those things. So and I feel like if the embodiment allows for it, like this Farhat robot, when you look at it, you would a naive person would definitely think that, oh, maybe the robot is actually sad. So it would be interesting to see like up to what's the extent, like how do we even quantize these things. So it would be fun to see that.
Yeah, there's a lot of skepticism about it, about emotional intelligence, and it is like the real difference between humans and AI. And let's see how far we get. If you see the large language models, it's already very impressive how well they're able to detect emotions. But I'm now also kind of encouraged also after your work to see that also the emotional expressions might be rather convincing and impactful. So thank you a lot, and I'd like to give the word back to the prorector.
Thank you, Professor Beckheng. Then I give the floor to Dr. Holler.
Thank you. Dear esteemed candidate, I would also like to congratulate you on a very impressive thesis. I think it's very novel, obviously, and very exciting. And was a pleasure to read. And also for me, it was very surprising how far the field has moved on, or how far you have moved the field forwards, especially delving also into the emotional domain. But that's not what my question is about. My question is not about any of the chapters either. My question is about your title. So the face says it all, and well, I would say it doesn't, because obviously the mouth and the tongue has quite a lot to say as well, and so have the hands, which produce a lot of gestures. There are posture movements, forward leans, head gestures, and so on and so forth. So my question is not why the title, but more generally speaking, how should you or how would you reflect on your kind of research and findings from a more holistic kind of perspective if you had chosen or if you had available a robot that has all the visual expressivity of Furhat, but also all of these other articulators and signals. And if you then had moved your paradigms into experiments with that kind of robot, how would you think your findings might change or your conclusions might change about gaze in particular in this case, or facial expressions even? Mm-hmm. And you can comment on any of the chapters if you want, and any of the behaviors.
Dear opponent, thank you for the nice compliment. To answer your question about the title of the thesis, the idea was basically to emphasize on the importance that face has on our day-to-day communication, because it's one small unit of the body, but it has so many things that is happening, including not just expressions or the gaze, but the head nods and gestures and everything. So that's why I thought it would be good to just emphasize on that. Coming to the other part, which is like if I made use of a robot which had different, let's say it was a full body like Amica, that's for example. I still believe that the findings from my research would still be like, it would still hold, because even if, take for example us, we have all the faculties that we need, but even then it has already been found that like gaze plays these important roles. So it's only natural that if we have a robot which has the facial expressiveness of a human being, we should probably harness those capabilities and try to see if these are perceived in the intended way that we think it should be perceived. So I would still say that yes, it wouldn't change my conclusion much. Having said that, I would take my findings with a grain of salt, because at the end of the day, when we are designing these experiments, there is only so many things we can mix and match. So our speech, and we are like mainly multimodal beings, that, as I would like to say. So everything. So if I am thinking about just the gaze, so let's take, for example, the joint attention. So that I briefly mentioned during my presentation as well. So I'm talking about the microphone. What I just did. So I looked at it, but I also pointed to it. So it's not just that gaze is sufficient for everything, but we also have to add more modalities that we see. And then the question arises, how do we combine? What is the combination of it? Like, is one thing enough, or what is the timing? Should one follow the other, or should it happen in conjugation of both of these things? So I think there are a lot of things that needs to be researched further.
So you think that if there was like arms, for example, and you have some uses of the referential gaze, of course, but then if you had pointing availability as well, you think that the robot manipulations that you've now implemented would be necessary to the same extent, or would there be a trade-off between the modalities in users' perception especially? Mm-hmm. So would they find it perhaps more natural if certain referential communication, let's say, was offloaded to the manual modality?
Yeah.
So is it overestimating currently what gaze does, or what's your view on that?
I don't think it would be overestimating what gaze does, because just from the evidence that we have so far, and specifically in the domain of face-to-face conversation, I mean, it plays a very important role. But specific parts of the communication, like referential gaze, perhaps, it would help to have the additional modality of pointing, perhaps, and those things.
So you think it would be additional and layered on rather than a
yes,
trade-off kind of thing?
I believe it would be layered on,
okay.
Perhaps.
All right. Okay. And then moving more into the kind of affective domain, mm-hmm. you've manipulated, gaze aversion and gaze direction. Mm-hmm. And you connected that to the equilibrium theory by Argyll and Dean. But in their theory, a really core element is also the physical proximity. No. It's something that you didn't manipulate. How did you choose, first of all, the distance? And is that something participants were free to adjust as well? Because I think it's quite a personally specific kind of, what do I find comfortable? Yeah. And if you were to manipulate it, how do you think that plays a role in your kind of findings in particular, and in the robot interaction.
So the distance of the participants, so they were not free to move around because Forhat has this range where it can detect the user, so they were kind of restricted to it. So the sitting arrangement was chosen partly by that, but also having it more of a comfortable distance, but that was mostly like a heuristic. So this feels a comfortable distance, and then we chose it. But that's why we did not vary the distance, but it was the participants were not free to move. So the distance was fixed. But if we would try to incorporate that, and then, like you said, so it's probably very individual in nature. So it depending on the person, it might be like a person might feel that this is close enough, or somebody might still be okay with coming very close. So I think if we could probably add that as another factor and keep what we have, the current experiment as the basis, and we do not change that, but we add another factor that will just be the distance, and we could see what happens. I would believe that we would still probably get the steering if the robot keeps on. But depends. So it's if it is within the personal circle, the distance that is considered as personal space, the effects will still be there. But if it moves beyond that, I think then it becomes difficult for the participants to even see the robot's gaze properly. So even if the robot keeps staring at you, you will probably also like just keep staring. So we might not find the same.
And now maybe quickly linking this back to the first part of my question. If then you have these additional modalities, so for example, forward leans or gesturing into the shared space, which also manipulate, so these additional modalities that also manipulate the proximity and the intimacy potentially. They're obviously on a different level than the gaze, but still, you still think that would just be, how would you think that kind of affects things?
So you mean
if the robot had arms and gestured into the space, or were able to lean into the space, you still think that the gaze behavior, effect of the gaze behavior, in addition with those signals, would not be different?
I think it would not be like completely the same, but because now we are like perceiving something more. But like I said, it depends on the context of what's happening basically. So if I'm talking and like if I move too close, then the immediate reaction would be I move back. But still, the coordination with the gaze still remains the same, right? So I still like keep looking at you. I still like perceive when you don't want me to speak. But there might be some confusion, of course. But I think it still will be similar.
All right. Thank you.
Thank you, Dr. Holler. We now move to the online members of the examination committee. And I first give the floor to Professor Bailly from CNRS Grenoble.
Hello, you hear me?
Yes, we can hear you.
Okay, so hello, Chinmaya et al. Thank you for inviting me and taking the risk of me asking questions. Chinmaya, very thank you for the autograph. Of course, I would have preferred to have more citation of my inspiring work. I see that you have added just Lea Eifliger as in the published book, so you are safe, but I would expect more. I have basically three questions, so three remarks. One is a general question on conversation. The chapter 2 is perhaps the most interesting for me. In the key control process of the gaze, you published in page number 31, looks like that the main objective of your control policy is to maintain attention. So somebody is speaking, you pay attention to him, to what he's speaking about, and after next, and you loop. What do you think about going a bit beyond that? When you have free agents, you have so-called conversational regimes. So the robot can speak to the two of them, only one, only the left or the right. The two speakers, the two users can speak together to have, for example, a common proposal and so on. So here you don't have any policy, in fact, to manage conversation. Could you comment on this?
Dear opponent, to answer the question, So you mean to say what happens when the robot is talking to
So
two different?
the two subjects are speaking
Yes.
together.
Yes.
Which one you are looking at?
Yeah. So I think purely from this algorithm, what it does, so what it relies on is the direction of the speech that is being produced. So it just directs its attention to the person who is speaking. So that's.
But if you are speaking to somebody, you,
yeah,
who I will look at as a robot.
Yeah. So as a
But
robot,
you are speaking, I will be looking at the other because your message is addressed to the other.
Yeah.
So I'm looking to the addressee,
Yes.
not to the speaker.
Yes. Yes, you're correct. That's so. Depending on where the speaker is looking at, of course, as a listener, I would also look at the same. That's for sure, and that's like we say is a limitation because we do not have this modality. So we are not tracking the gaze behavior of the participants, and that's something that we include in one of the chapters. And we say that okay, we should also have this as a future work.
So just in summary, I was expecting perhaps more state of the art on what is a conversation.
Yeah.
Because if you want to manage a conversation, you have to really understand
Yes.
Why you are speaking. Do you ask questions? Do you deliver information?
Yes.
The direction of the information is important in the gaze.
Yes, definitely, totally agree. So yeah.
Second question is about evaluation. It's a key issue now for technologies. So in page 60, in fact, you evaluate, in fact, by just simple MOS scores the policies. But I was wondering if you, in fact, the gaze condition, so aversion versus non-aversion, has an impact on speaking time, on task completion time, and so on. So I think it's time now to get further, to be more imaginative in the way we evaluate technologies.
Yeah,
What is your opinion?
I totally agree. And this is also something, as I progressed with my PhD, I also came to realize more and more that evaluation is a key concern in the field because, I mean, we can just choose what we want to evaluate and then what happens about the other things. To briefly give you information about the duration, so I did measured the duration and we did not find any significant effects in that, any significant differences. However, recently, I was working with another colleague from Bratislava who was looking into what happens to alignment in this type of setup. So he used my data. And so we got nicely transcribed turn details. So for me, what I was considering as the duration, speaking duration of the participant was when the robot stopped speaking till the robot started speaking because I could not annotate it, I did not have much time. But after he did that, I did look into the turns. And it seems like there was indeed a significant difference between the turns. So it seems like when the robot averted its gaze, participants had more turn durations.
Okay, last question because we have to hurry. It's about audiovisual emotion. As you know, in fact, emotion is also in the voice and in the mouth. For example, smile is clearly audible and visible on mouth. And so I was questioning about, for your result, in fact, what is the interplay between the verbal and co-verbal display? Because in fact, if you ask the people, in fact, to react to facial display, which are just, considering the upper face, without the tone of the voice, which is, because I have a thesis on this, so I'm working on the audiovisual text-to-speech synthesis. And so it's really very important, in fact, to have some kind of fusion between the two information. Yeah. So how can this have impacted, in fact, your chapter 4 and 5?
So just to just to clarify that I understood your question correct. So what would have happened or if I had the other modalities like speech and the gaze?
You have speech. You have a normal TTS,
Yes.
which is
Yes.
just in fact a narrative style. And after, with this very neutral tone of voice, you display in fact emotion basically in the upper face, because the lip sync is just also normal.
So
displaying. So I think that you construct monsters. In fact, if you don't have, in fact, a joint generation of speech and emotion and facial display.
Yes. In the fourth chapter, we did display the entire face. So they had a face-to-face conversation with the robot. And then, you are correct that it was just a normal TTS and then just expressed. In the fifth chapter, however, there was no speech or no lip sync at all. So it was just that participants saw a video of a smile. And there was no associated speech or any lip sync. So it was just to see that what is important or what plays a factor in recognizing or perceiving these expressions on purely expressions. But of course, context is definitely needed. So definitely that's the next step, the logical next step, that we need to have context, because how often is it the case that I see someone just smile? It's limited in that sense.
It's not only context, it's really audiovisual emotion. It's not. And after, of course, it has to be grounded by some events or whatever. But, okay. So thank you. I leave the floor.
Thank you, Professor B. I would now give the floor to Professor André, Universiteit Augsburg.
Yeah, dear esteemed candidate, thank you very much for the very interesting work. I was impressed by the variety of studies. And I would like to discuss with you decisions regarding the experimental design. So normally when you design a study, you have to find a good balance between naturalness and controlled setting. And I had a feeling that you actually were very much in favor of a controlled setting. And to start with chapter 4 on the emotion recognition, so can you explain the role of the images? So for the study in chapter 3, you had a conversation. In chapter 4, you actually had a game-like scenario. You used large language models. And one could say, okay, the images just caused problems because there was the danger, of course, that people looked more at the images than at the robot. Also, of course, what the people say depends on the images. So why didn't you focus on a social conversation on a given topic between the robot and the human user?
Dear Operan, thank you for your compliments. So to answer your question, like you just mentioned, that it's a delicate interplay between control and being able to make the conversation as natural as possible. So in chapter 4, the idea was that we wanted to ensure that whatever was being discussed had some emotional content. So we first thought maybe we could have some sort of a storytelling and give them display some images, or maybe show some random pictures, which are maybe, for example, there is a person walking and then he falls down. So a sequence of images, and then ask the user to describe it. And then in the process, hoping that the description would trigger some sort of reaction from the GPT. But then we felt that it might not be sufficient because, during that time, GPTs were also not very reliable. So it was one of the very first studies so it was prone to hallucination and everything. So then we thought, okay, instead of using GPT to generate these stories, we needed to restrict it more so that we can get a reliable output. So we thought, okay, why not consider the entire process as an emotion recognition in conversation, and that way we can ask GPT to just classify the emotions, right? And then the idea was, okay, if we show pictures, I think it makes makes the case that yes, the conversation will have at least some emotional content, not necessarily exactly what the picture are describing. So there were cases where there were pictures of somebody standing at the edge of a cliff. And people interpret it differently. Some people interpret as fear. Some people get afraid, oh, this person is going to fall. And other people interpret as if, yeah, it's like this person is enjoying his life and looking at a very nice view. So even though the pictures as classified in the data set were classified as fear, but during the process of conversation, we found that it's interpreted differently. And in this regard, I think it was a good way to experiment. Also, it made for a very engaging conversation between them. So both of them had a to and fro, and there was no specific. So it was also instructed to the participants that there is no specific order that is correct, and it's highly subjective. So participants were more encouraged to discuss more and more with the robot. So that also made it possible that the participant did not just keep looking at the touchscreen, but also looked at the robot's face.
Mm-hmm. Maybe a provocative question. You talked a lot about empathy, and there are different types of empathy, motoric empathy, cognitive empathy. And I had the feeling in your case it was basically mirroring, and there are applications, of course, where mirroring is probably not the best thing to do. So, for example, when a student is depressed because of bad performance, the teacher should not simply mirror the depression. Mm-hmm. And so I had somehow the feeling the emotional concepts were kind of simplified also, yes, because you reduced everything to the Ekmanian, yes, emotions, and you might have completely different feelings when looking at images.
Yes, I totally agree that it was simplified to fit into the realms of the study. So it was definitely a limitation that we just focus on these 6 basic emotions. And yeah, I totally agree with that. It's a limitation, and I think further work needs to be done to move beyond just these 6 categories, and perhaps also think of innovative ways of how we can have more interactions, but also make it as natural as possible. So we don't just restrict it to a specific game or anything, or just make use of affective images, but maybe there are clever ways of eliciting emotions. Maybe the robot can say something, and then there is a response, and perhaps now in this case, the robot is not mimicking, as you say, and then in this case, so perhaps the person gets angry at something the robot said, and now the robot cannot get angry as well. Perhaps the robot has to be sad that you got angry with me. So definitely that's something that can be looked into in the future.
So last question regarding the experiment. So coming to chapter 5, I was a little bit surprised as Gerard regarding just showing actually the upper face region. So in the past, there were a lot of experiments, I think even by KTH, where actually people had a face talking or not talking. And when talking, even if you don't hear the audio, it's more difficult actually to recognize emotions. And so I was wondering, why didn't you simply show a talking character versus a non-talking character to see the impact of the different contributions of the face in different conditions, talking versus not talking, because it's very unnatural to cover part of the face. Maybe in the corona with the mask, but normally not. Yeah.
So that was kind of also a motivation of sorts. I came across these studies where they studies like how was emotion perception impacted when people were wearing masks, and that got me thinking, oh, this is an interesting topic. And also to mention that nowadays, if you notice that the robot that I showed at the beginning of my presentation, except for Amica, none of them had even face, and that got me wondering, okay, what plays an important role in, or what is a factor that influences perception of emotions from a robot's face? And that was the topic that I wanted to see. Like, so what is important to be modeled at the very least on a robot's face? Do we even want to have the entire face? Do we want to go to all the difficulty of modeling everything, or is it enough if we just have the eyes? And that was the basis or the thought behind this study, which is why we showed just videos of the eye region versus the entire face. So that was what we were trying to see and get at.
Okay, thank you very much.
Thank you, Professor André. And now give the floor to Professor Bosse.
Yes, thank you, Mr. Rector. Dear candidates, it's my pleasure to continue this opposition and also exchange a few words with you on the topic of your nice dissertation. But before I do that, let me also give you some additional compliments. I just wanted to say that I've also read your thesis with much pleasure, and what I particularly appreciated was the combination, how you combined on the one hand computational modeling with the empirical studies on the other hand. So also working in this area myself, I know that what you often see is a focus on one of the two. So are there some studies where scholars really develop complex computational models, but at best only evaluate them in like short usability studies, or they take off-the-shelf models and really focus on quantitative empirical studies? But yeah, you combine both, so I appreciate that a lot. So thank you for that. But of course, I also had a few questions that I wanted to ask you. And the first one, again, is on chapter 4. So chapter 4 is popular today. Yeah, I would like to start with a simple clarification question, but I think it's important. You may answer it really briefly. And that is about how you manage the dialogue in chapter 4. So you explained that you use GPT 3.5 to predict the robot's emotion based on the dialogue history, so the last few utterances. But how do you determine what the robot says itself? Is that also Wizard of Oz like in the previous chapter? Is it a scripted approach, or how does it work?
Dear opponent, thank you for your compliments. Yes, it was scripted, so that's how we managed. So we passed the past 3 utterances that have taken place between the robot and the participant, and we send it to GPT and say, what should be the robot's emotion for the next utterance. So it's not, so we kind of force it to predict what should be the robot's emotion, given the context. And then we basically feed it. So while the robot is uttering the next sentence, which is already scripted, we show it, we display the expression on the robot's face.
Yeah, okay, so to make this very clear, the prediction of the emotion is based on GPT.
Yes.
But the generation of the utterance itself is scripted.
Yeah, it's scripted. So there are only like a few options that it can say. Okay. So if let's say if the topic is something about the picture, so the question would be like, what do you think about picture 1? Let's say that's what the user usually asks, and then robot gives an explanation. So robot is already explaining some emotional dialogue. And then, then there will be a response from the participant saying, "Oh, that's interesting, yeah," or maybe they comment further on the same topic. And then in that case, what was happening was, so it was then we would select one of the relevant answers and then continue the conversation further. So.
Okay, but this selection of the answers, that happens automatically. There's no human in the loop there. Is there?
I'm trying to think a bit.
Okay, yes. And
perhaps,
I find it important because it also has impact on some of the other questions I would like to ask.
It's definitely, so the turn-taking aspect was always, so there was a wizard who was clicking that, okay, now it's time to answer. So yes, it was wizarded, so.
It was wizarded.
Yes,
okay,
wizarded.
So there's a human still in the loop who decides when. Okay, okay. So if that is the case, and how exactly do you determine what the robot says about these images? For instance, whether the robot agrees that this is a happy image or that the robot thinks it's a more sad image. Is that also a human who decides that?
So that was already pre-coded. So we just so the answers from the robot or the description of the robot based on that one image is fixed. So let's say, and that was done basically from the data set. So if the example that I gave, so let's say the example was somebody standing at the edge of the cliff and it was tagged as fear, then the robot always perceived it as fear. So there was a scripted answer that was fear. And then that kind of initiated a dialogue. So participant thinks it's a person enjoying his life, and robot thinks it's fear, and then that made for a nice conversation and exchange. And then what happened was that allowed for us to also see if GPT can take this into consideration and change. So now GPT doesn't always predict fear for a robot, but also takes into account what the participant is saying. So participant says it's enjoyment, and now GPT perhaps comes up with saying surprise, because now it's the robot is surprised. So, but I don't think that's something like that. So.
Okay, that's very helpful, thank you. So to put this in my own words, basically the robot has some kind of knowledge about the emotional value of the pictures already stored in the database and uses that?
Yes.
Now, if that is the case, that's also interesting in the light of the discussion you had before with Professor Andre, because then I would say it's not pure mirroring what the robot does, right? It doesn't only reflect the user's emotion, but also some of its own emotion that it has in this database. Would you agree with that?
Yes, it was very context dependent. So depending on how the conversation flowed, the expressions would change. So it's not, like I said, it's not always the case that it will reflect what's in the database. And this is also something that's mentioned briefly in the discussions part of this chapter, where we say that, or if you also go and see the results section, where we say the reliability of the GPT model, and we mentioned it there. So we say that this is basically giving an idea of how often the GPT's predicted emotion aligned with what we have in the database. And you can clearly see that it's never like, it's probably always around like 50s or around that. So that kind of says
there are
that
some deviations.
Yes.
Okay. So that's very interesting. Yes, and so given the fact that the robot's own knowledge of the images is somehow involved, would you say that that may also have helped for the task performance? Because at some point you measure how well the people are at, I think, classifying or like ranking these images, right, from positive to negative. But I can imagine if the robot gives away some information about the images, that also helps there.
Yeah, sure. But at the very beginning of the experiment, it was explained to the participant that you need not agree with what the robot always says. The robot can make mistakes. So it was already kind of told to them that, it might be the case that robot is wrong. So you do not necessarily have to accept whatever the robot says. So that kind of perhaps avoided that being an influencing factor in the higher task scores, because I remember that participants were very adamant, and at times they were like frustrated, like, what is wrong with you? I do not agree with you. And then they just went ahead with whatever choice they made. So
so they didn't always agree.
No.
I have one last question, if I still may. But,
short question.
It's about your choice of Ekman emotions. We already had some discussion on the Ekman emotions. I noticed that you use 5 categories and the neutral category, but it looks like you did not use the rather standard emotion disgust. Is that correct? And why did you leave it out?
I think the idea was so if I had followed the Ekman coding of emotion for disgust, and it was very like, it was very exaggerated, as we mentioned. So we wanted to exaggerate the emotions on the face of the robot, and disgust was something that's not something we normally like use in our communication, day-to-day communication, as Ekman's coding source. So it's not like we'll just express like something like it. It's very subtle in human-human interaction. So we just like probably just raise our nose a bit, and that made it. If I followed that, then it would be very subtle, and then I was not sure if we'll be able to like perceive and that. So yeah. Also, the other thing was from the database that we used, the images that were available for disgust. They were kind of disturbing, so we could not actually use that. It might be disturbing for the participants to see, so we refrained from using disgust as an emotion. That's why.
Okay, that makes sense. I think my time is up, so I'll give back the floor. Thank you,
Professor Bosse. Then I give the floor to Dr. Liesenfeld, the last member of the examination committee.
Dear Chinmaya, also from me, congratulations already at this point for this completing this very interesting thesis, which I read with really enjoyed reading it. So here's my question. I'd like to hear from you what you have to say about the ecological validity of your findings, of your observations, and of your implementations models. So in your quest to better understand gaze and emotion in interaction, did you maybe even find useful qualitative empirical work conducted outside of the lab, maybe in everyday settings or maybe in real world settings?
Dear opponent, thank you for your compliments. These were some of the things that we're testing for the very first time. So, for example, the influence between the robot's gaze on human gaze behavior. So I did not really find anything that was done outside of lab settings, at least for the specific things that I focused on. But I'm not sure if I answers your question, or maybe I misunderstood.
Okay, so the question is aimed at your your basic science understanding of what is interaction and what is a conversation, right? So I was a little bit surprised to find that in your thesis you didn't bring up the term conversation analysis, ethnomethodology, different strands, sociological work on what is interaction or group interaction. So did you look into scientific work of interaction in the widest sense?
Yeah, I think it was briefly looked upon, I would say. I did look into different fields to better educate the decisions that we're making. So we did rely on various prior works from other fields. For example, when we modeled the referential gaze in chapter 2, we did rely on prior work which said that, okay, we direct our gaze perhaps 1,000 milliseconds before we refer to it. So yes, there was some information, but it was mainly reliant on the prior work. So it was we're building upon what has been done in the field of human-robot interaction and then see how we can better that. So yeah, it was a mixture of both.
Okay, so that is prior experimental work for the most of it.
Yes.
Okay. So then the other end of the spectrum. So would you claim that your implementations and models are ecologically valid? Are they production ready?
I would say the gaze model is perhaps production ready because it performs well and it can be scaled fairly easily because it's very simple in the sense that if you feel that, like what Gerard was saying, so if you feel that we need to also take into account the gaze behavior of the participants, you can just add it as a module and then the algorithm can also take that into account when it's planning. So I would say that would be one of the strongest algorithms that's been developed. On the other hand, the algorithm from chapter 4, which was the LLM, I think the performance would have increased fairly well if I just use it now, considering the advancement that has been happening with LLMs in the past 1 year. So it's, I believe it would be even better, perhaps, but that needs to be seen. I mean, with LLMs, it's nothing is certain, but I think these can scale well in today's world as well. So.
Yeah, so maybe last quick question, picking up on what you just said on LLMs or the LLM landscape changing so fast, how did the invention of ChatGPT change your work? That came, I think, in the last quarter or last third of your PhD. Was this a game changer for you? How did you think about that?
I think it was definitely a surprise. I was surprised by it, then I was blown away by it because one difficult component in designing interactions with robots is that we have to anticipate what the conversation would be like. We have to script many things, and that's kind of very time consuming and also not very intuitive. So it's also very dependent on the developer who is designing these things, and the model is as good as I can think of. So if I am not very good at anticipating what the conversation or what turn the conversation can take, I might not have just an appropriate answer. On the other hand, with GPT, it made it very easier for us to come up with entire sentences and conversations. So it kind of changed that aspect of human-robot interaction. So we could now focus more on the decisions, and we can leave out just having to do the tedious work of writing. If we have the correct prompt and if we can make the correct decisions, we can just rely on the large language models to come up with, generate these sentences as replies or responses, and that I think helps a lot with human-robot interactions.
There's room for a short follow-up question, if you will. Dr. Liesveld?
From another member?
Yeah. Yeah.
Okay, so last question for you. It's very interesting to see that these large language models are so good in picking up emotions. So to what extent do we really need the robot face what is it really adding to the large language models?
So to answer that, I think we are now, so it's a very intuitive in the sense that, so with large language models, it's if we just use a large language model, it's just a text-based interface. Now when you add robot's face, now we are in like co-presence physical setup. So even if, let's say, when I'm chatting with something, let's say ChatGPT, and GPT just says happy, that doesn't really make sense in a context of text. But whereas if it expresses the emotions, if we can express the emotions on the robot's face, you can easily understand, okay, this is basically the emotions being expressed, and like you understand that this is the expression or the emotion. So I believe that embodiment matters here, and that's the addition.
The defense is hereby concluded. I give the floor once again to the candidate.
Having defended my dissertation to the best of my ability, I would like to thank you, Rector, and you, my supervisors and co-supervisors, and all who have honored this ceremony with their presence.
You, the doctoral examination board, will retreat for its deliberations. On behalf of the doctorate board of the Radboud University Nijmegen, we have decided to award you the degree of doctor. I invite Professor Hagoort to discharge the task assigned to him.
With the power entrusted by law to the doctorate board, I hereby confer upon you, Chinmaya Mishra, born in Burla, the title of Doctor from Radboud University, Nijmegen, to which are attached all the associated legal and customary rights and duties with respect to academia and society. As proof thereof, I present you with this doctoral diploma signed by the rector and the doctoral thesis supervisors and co-supervisors.
Get seated. Please take your seats.
Dear Dr. Mishra, dear Chinmaya, congratulations with the degree of doctor that you received today. You did your PhD in the context of an international European project called Conversational Brains, COBRA in short. If brains start to have conversations, they exchange linguistic expressions, messages shaped in the form of sounds, words, sentences, and discourse. But conversational brains are not just brains in a vat. Instead, they are embodied. As a consequence, the linguistic signals that conversational brains produce are accompanied by gestures, facial expressions, eye gaze, and muscle configurations that express emotions. All these signals are an integral part of human communication. For the first time in human history, we have now entered an era in which we no longer have conversations with only other brains, but also with silico-based devices. But with all due respect for the linguistic power of large language models, such as ChatGPT, they miss a key component of human interactions, namely these concomitant social signals. That is why we need social robots and avatars to optimize human-machine communication. In the near future, humans will converse with robots and avatars on a daily basis. Hence, it's crucial to understand how we can optimize the social robots' production and the human appreciation of their social signals, such as eye gaze, emotional expressions on the face, etc. This was the key contribution of your research, and you discovered which aspects of these social signals matter most. This will certainly help in the further development of social robots and their communicative efficiency in interactions with humans. The relevance of your findings was quickly picked up in the media in the Netherlands, Belgium, and Sweden, among others, showing the timeliness of your research. And Professor Skanse will discuss in a minute the relevance of your work in more detail. You started your PhD research in the aftermath of the COVID pandemic. Nevertheless, you finished your thesis work within 3 years, with nearly all chapters being published. This, in of itself, is a remarkable performance. You were always open to feedback and comments, and very quick in integrating them into your thinking and writing. Sometimes you were a bit anxious if this arrangement between Furhat in Stockholm and a degree at Radboud University was going to work out. I did my best to reassure you that it will work out, and today has proven me right. But of course, completely due to your own qualities. You are a hard worker, but also someone with a good sense of humor and optimism, a golden combination that will bring you far in life. Before I hand over to Gabriel, I would like also to congratulate your wife, your parents, further family and friends here and abroad with this tremendous success of Chinmaya. You should be proud of him. I hereby hand over to Gabriel.
Thank you very much. So in this project, I have served the role as Chinmaya's supervisor at FERC Robotics, so as industrial supervisor, because Chinmaya was an industrial PhD student in this project. I'm also professor at KTH, so I have tried to give input from sort of both directions. And Chinmaya has also had an excellent group of supervisors, of course in the form of Peter, but also Susanne and Rinus here has really helped you. So I think you've had a good interdisciplinary team representing both academia and industry. So when we recruited Chinmaya, we had a lot of different candidates to choose from. And we had a lot of interviews, and Chinmaya also, since he was supposed to work in a company, you got the chance to work with the people at Furhat. And everyone liked Chinmaya a lot. His warm personality, but also his curiosity and your passion for this topic. So as a day-to-day supervisor at Furhat, it's been a pleasure to work with you. I have supervised a couple of PhD students in the past, and it's always sort of you have to prepare as a supervisor for a bumpy road with lots of unexpected turns. But I must say that this trip has been unusually smooth, actually. So you have always been very diligent, and we have had a lot of interesting discussions on this topic during the years. And as we've heard, like you've not had the best sort of very challenging setting with this pandemic. And in Sweden, we don't do the PhD in 3 years, we do it in 45 years. So it has been sort of very impressive to see you being able to do this and actually complete all your research well in time before 3 years had passed, actually. So, and of course, for Furhat Robotics as a company, your topic has been of course, it's the heart of what we do at Furhat. But also from a sort of more scientific perspective, I have really enjoyed working with you. I was very curious to see the outcome of your experiments. I wasn't sure that the robot's gaze aversion would actually affect human gaze aversion in the end. So that was super interesting to see for me. And of course, it's not just us being impressed, it also all the articles that we see now in the popular science press writing about your research output. So it means that you're not only a good researcher, but you also manage to do research that is sort of feels relevant for a wider audience. And what I've especially liked to see during those years is the way you have grown in terms of independence and in terms of increasing your rate of productivity. As I said, we have had a group of supervisors here, and the COBRA project has given you opportunities to use those, and you have been really good at using those, I think. I think the collaborations that you have done with Susanne and Tom Offrede, and then here at Max Planck with Rinus and so on, has really shown that you are very good at collaborating and using other people in a very productive way. So as a supervisor, I think all of these are important signs that you have become an independent researcher. And I'm very proud of you, and I think you are very worthy of your new title. So congratulations.
Thank you. As acting rector, I would also like to congratulate you, Dr. Mishra, with this achievement. And before we close the ceremony, I would like to give the members of the committee online a short opportunity to congratulate you as well. Maybe start with Professor Bailey.
So, bravo. I think nowadays people are more working on drones than on social robots. So, I hope that you will find a job in this research and development area. So nice to see you on board and read. Carry on reading, doing and reading. Thank you.
Thank you, Professor Andre.
Yeah, congratulations on the great work, and I really hope that you got enthusiastic by research, and will continue doing research because we need people like you, and all the best for the future.
Thank you. Professor Bosse?
Yes, Dr. Mishra, congratulations on the job well done. As I already mentioned, I really liked your work and I really appreciated this combination of both modeling and empirical work that you tackled. And also my compliments for your flexibility in actually adapting to the sudden rise of large language models, because I think it's really nice how you included that, let's say, halfway your PhD trajectory in your work. So yes, also from my side, good of luck in your future career. And I guess the only thing left to say is that I really recommend you to have a good party this evening, because that's also very important. Good luck with that.
Thank you. And then finally, Dr. Lieseveld.
Congratulations, Chinmaya. I was impressed not only by the content of your thesis, but also by the way you presented it by your writing. So this is really an increasingly undervalued academic skill, which I believe will take you far. So congratulations, and let the party begin.
Thank you. We have now come to the conclusion of this ceremony. Would like to ask you all to stand again one final time. We close with the following words: Gratias tibi agemus omnipotens Deus pro omnibus beneficius tuis. Qui vivis et regnas per omnia saecula saeculorum.